Okay, good morning. We were originally supposed to talk today about licensing and stuff like that, but after last week's meeting, we said we talk more about BOS. So, what are we going to do today? First, I want to give you a little update about Mars Garden, because I've been in contact with people and found some stuff. And then we'll talk about BOS, which is an acronym for BOS Operating System. And as Eric pointed out, there's only one level of recursion, because the second BOS is a species of cattle. Okay, so I found some slides which talk about what you expect to have in a Mars garden. Mind you, Mars garden is ideas that you can have a little section in your garden, or maybe even in your house, which is set up for the rover to walk on, and it somehow models what Mars looks like. And you can use it to train or check mobility and other activities. So Mission Control Space Services has one of these Mars gardens. I was unable to download a picture of it, but it's very big. It's like a football field. But the features that it has, you can notice, you can have uncompacted regolith. Let's just call that sand. You can have rocks of various heights. The ground is not flat, so you have ripples and craters, and you have slopes. And I'm still trying to get together actual numbers for these things. But here's an example of a picture from an actual mission. So what you see here is what it looks like on the map. This is a picture of the actual building of it. And here is a theoretical explanation of how it's formed. So an asteroid hits over here. It causes this interesting shape. The cracks here allow water to flow, and you get some hot springs, and that's what it looks like in the field. The same company has an indoor lunar analog test bed. Okay, this is what the moon looks like, and they have a brochure. You see what the room is like. Okay, so they have an actual room indoor in some sort of warehouse. And you can have rovers walking on it. We'll ignore the mission control software. This is to give you a feeling of what they built. Let's just say it's about 20 meters by 30 meters and different areas and so on. And as I said, I want something much smaller. I don't know if it's possible. Say 3 meters by 3 meters. The size of the room in somebody's house. And they have different types of terrain. I'm just showing you these pictures to give you a feeling for what gardens look like. So different parts of the moon look differently. So they do them differently. And basically, this is the kind of map that I want to generate. You have different objects in different places. Each object has properties. Okay, just 1 second. Was one more picture here. These are all pictures from the point of view of the rover, which look like the moon. Somebody left some footsteps. And you can tell the size of the rover. It's about this size. So that's this one. They're not the only ones. The Canadian Space Agency has a Mars yard. You can see the size by looking at the car, the roads. Remember the crater, a cliff, weird shapes. And apparently there's something called the European Rover Challenge, where they built a area and people had to bring rovers, and the rovers had to do some sort of activity in the areas. Anurag, are you familiar with this at all?
Yeah, so the university I was at here in Oulu had participated in this around 12 years ago, or 12, or maybe almost 13 years, 14 years ago. I think they participated twice, but I was not there in the lab when they participated. But I have worked with the robot which participated in it.
Okay, so they have this every year.
I don't know they conduct it anymore or not.
Oh, that's
So,
why I'm saying.
So they do.
Picture from 2021 or 20.
Okay. So recently the lab has not been participating at all, but like the lab has participated previously.
So I'm just wondering whether there's something equivalent in the US, and if there isn't, there could be. Okay.
There is one at my alma mater, actually. University of Michigan just opened last year this Mars yard as part of the robotics lab. I'll post a link.
Yeah, I saw it, but do they have a challenge, once a year that everybody comes to compete on?
Oh, they have a rover team, but I don't know that they do a challenge. I thought you were asking about whether they have a yard. Sorry, misunderstood.
No, because if you look over here, Canadian Space Agency has one. And the picture over here is Jet Propulsion Labs. They have their own little Mars yard. And here is something done by Airbus. So maybe I switched the two. Not so important. Okay, so there are multiple yards, Mars yards. What I like
this year it is in Poland.
Last year. I think it's finished, just finished.
Okay, yeah.
So, but the point is that it happens every year. It's a big happening. People come with rovers, and somebody uses a tractor to set this up. And I'm just saying it could be something interesting to push. Okay, so any questions about the Mars yard? Fine. Oh, by the way, I don't have anything to update about my rover because my rover hasn't done anything since late night Tokyo. So there's nothing to update. Okay, but I'm going to present opinionated point of view about BOS, so feel free to disagree or present an alternative. And I think I've been working with Eric on this. One of the things I've done is we've actually started working out what it actually looks like. So there's already a little bit of code, like 2 lines. Okay, so what is BOS? We're not quite sure yet, except that we call it an operating system for rovers. And obviously we don't have a logo, so we need a logo. But more practically, we need to talk about metaphors. Most systems have human understandable metaphors, like a desktop or file system or streams. And I don't think we have any metaphors defined for BOS. We talk about actuality. The rover knows where it is. You have a world, but that's not a metaphor. That's an actuality. We also don't have definitions of, I don't know, objects or abstractions that are suitable for a robotic operating system. Again, location isn't really an abstraction. It's a parameter. We have talked a little bit about UI, and when we say UI, we're even talking about something at the level of a terminal. What kind of commands do you give BOS when you give it commands? And I just want to point out there's commands you give in order to use it, like ls in Linux gives you a list of files, and there's commands you give it when you code it, like when you write a script shell. No idea yet. There's something called an operating environment. So if you have a system, you have all sorts of common tools and protocols and formats that everybody using that system has. Eric pointed out that that is perhaps the most important output we can create, is defining an operating environment which is good for people programming rovers, because that will generate shared language and make it much easier to have shared, code and components between different rover builds. So far I've said all the things that we need. What we do know is that BOS is not the part that controls the software brain. In other words, if you have a CPU with some memory and a hard disk, you're going to have Linux on it, or VX, or some operating system. That is not BOS. That is a operating system which controls the brain. When we talk about BOS, we're talking about the rover as a whole. So you can look at it. Are you people familiar with BIOS? So anybody whose computer used a Microsoft computer, you have the operating system, but when you turn on the machine, there's a basic input-output system, which is hard-coded and stored on one of the chips and defines the basic interactions with what's happening on the board. So from the perspective of BOS, Linux is BIOS. It's just a layer that gives it services. And perhaps as a definition, so we'll know it when we see it, BOS should be as invisible to the programmer as, let's say, Linux is. Now, I know Linux is not invisible to the programmer at all, but many parts of Linux are invisible, and the parts that are visible are very, carefully exposed. So when we have a BOS, it should feel the same way. Now, obviously, some of these definitions exist simply because we want to explain that we are not ROS. Okay, when you set up ROS, for example, it is not invisible to the programmer. So, what does a regular operating system do? First of all, it gives services to running programs. It provides safety and reliability to the hardware and to the programs. If you only have one program running, you don't really need an operating system. You just need a set of low-level routines. So perhaps we can say that the reason why you have an operating system is because you don't really know what you're going to be doing with your computer. Because if you knew what you were doing with your computer, you just write one program that does it. So you need some layer which gives you coordination and services for these things you don't know about yet. Now, I'm comparing it to BOS. So we assume there's an underlying operating system to handle all of the software level stuff. We know there's going to be multiple programs running simultaneously simply because that's, easy way to code, but the programs are all at the level of the operating system. So what's happening at the level of BOS? Can a rover do multiple activities at the same time? Can the rover walk and chew gum at the same time? That's 2 activities, okay? Does that really need an operating system? And we have a big question, what does it mean safe? Okay, computer on my desk, other than doing a command like delete all files, is pretty safe. It's not going to fall over, it's not going to break, it's not going to catch on fire. We can't say that about a rover. So as you see, I'm still trying to figure out what is RoS doing here. So here's some thoughts about activities of a rover. First of all, very few activities, if any, are internal to the rover, and very few of them are easily reversible. Okay, when you have a computer program, you can save a state, you can go back. Nobody knows better. When you have a rover, if you took a step forward and you take a step back, you don't know where you're going to be. Now, even the ones that are internal, like let's say calculating position or generating a map, they affect the state potentially for all the programs using the rover. Okay, so if the rover updated the map of where it is, any program that needs to know location will probably want to look at that. I am distinguishing between activities and missions. A mission is some overarching goals that you have getting from point A to point B. So if the rover was given 5 different missions, you have to get from Seattle to LA, and you need to buy some coffee, and you need to stop by in San Francisco and see if the Golden Gate is still standing. These are missions, and you have a planning system, long-term planning, and it makes plans and it decides what to do. So 2 interesting things. One, these are not activities. It's not something happening now while the rover is working. It's a plan the rover has. And second, juggling these missions is much more complicated than scheduling of processes on a computer. When you have an operating system and you have processes running, you have to schedule them. You have to make sure no process is starved. You have to make sure that everybody gets access to the resources that they want and within reasonable time. Some processes need to get it faster, some slower. But all in all, it's a simple scheduling problem, only made difficult because you want to do it really quickly and efficiently and be as fair as possible. But when we talk about these 3 missions I talked about, that's not the issue. What's the shortest way? Where should you go? What happens if you have a problem? How long will it take? These are all complicated planning problems. So this is a question to you to wake you up a bit. Can you imagine a rover that's doing, let's say, even 3 simultaneous activities?
You give several examples of what an activity is not, but you haven't given any examples of what an activity is.
I'm glad you noticed.
So do you mean something at the level of abstraction of like running the motor loop, in which case that if there are 4 motors, there'll be 4 activities? Or do you mean something higher level, like a, I don't know, a processing thread that claims time on the CPU?
Well, personally, I didn't mean either one of them. In other words, the first one you said is not an activity of the rover. It's like telling me that I'm doing two activities because the muscle's here holding my arm up and the muscle here is exactly balancing it. That's not at the conscious level. Okay, I have an activity. I'm talking to you people. At the same time, I'm moving my hands. Okay, that's two activities. I'm not sure exactly what an activity is. I know it's not a mission. And I know it's not even as low level as turning the motor on, because turning the motor on is something that happens below the operating system. Okay, so if you take a Linux computer, it has, or even this Windows computer I'm running on now, the operating system probably has hundreds of different processes running now. But actual activities that it's doing, I think it's only doing two. And they are Zoom and this particular screen. In addition, there are more activities happening in the background, waking up and going to sleep. We have Chrome has its own operating system and the various programs that wake up every so often and check something and then go back to sleep. Okay, possibly you would consider listening in on the network to see if something came in to be an activity of the operating system, but not an activity of the computer. As a user, none of that matters to me. So I would say activity is something which is managed by the boss, and all these other things are something which are done by the boss. So maybe an example of an activity is walking or drilling a hole in the ground looking for a sample.
In terms of operating system, activities and missions, both of them are processes, no?
No. A process is a unit of the operating system. An activity probably includes multiple processes. Let's talk about walking. So if you have a boogie-based rover, you have perhaps a process for each one of the motors, and you have another process which is collecting sensor information and integrating it. That is not an activity. That is, like I said, that is done by the operating system. It's not being managed by the operating system.
So one thought that occurs to me here by analogy to the human brain is, if you look at like the idea of the subsumption architecture and like the lowest level process abstractions, let's call it, they are like completely automatic things controlled by the spinal cord. One level up, you have the brain stem. One level up, you have the cerebellum and so forth, until you have fully open loop loops that happen with like the neocortical control, right? And the interesting transition boundary between unconscious, closed loop, sort of automatic, very rarely touched kind of behaviors versus more open loop, which have like some potential of bubbling up into consciousness, that tends to happen in the Purkinje cells of the cerebellum. And these are kind of like supervisory neurons. And what they do is they monitor activities. Like the example I'm thinking of is if you're throwing a ball at a target, and if you wear prismatic glasses so that your field of view is shifted and you miss by like say 15 degrees each time. This is an experiment they do often. Now that's the kind of sort of misregistration that Purkinje cells pick up on and then adapt to. So normally throwing a ball is like barely conscious. You're just throwing. Maybe you'll adjust your error based on error a little bit. You'll retarget. But if it goes wildly wrong, like 15 degrees off each time, a certain part of the cerebellum kicks in, namely the Purkinje cells, and retunes the throwing circuit. So to me, that sounds like approximately the way you're describing walking. In this case, throwing a ball, the supervisory monitoring process of throwing a ball is the activity. And same way, I'm sure with walking, For example, if you, I don't know, broke a leg and you're limping and you kind of have to consciously monitor it slightly, that might be a similar mechanism. So is that roughly the right level of abstraction in the stack?
Maybe. I don't know. I have 2 more slides which talk specifically about, I think, about the model you're using. But I definitely feel that the level of how do I move my legs, or integrating information from the sensors to know if the rover is straight or not straight, is not an activity. It's something that's probably managed by BOS. Otherwise, what do we need BOS for? And so can anybody suggest a rover that does 3 things at a time?
Can we choose one of the Boston Dynamics rover or robots or whatever?
Can I try my rover?
Sure.
So since my rover doesn't have a operating system, it's a little easier to it's really what all the code does is try to do more than one thing at a time. So if it's moving, that's one activity. On a schedule, it actually has to prepare information that it's going to send back about its progress on that. So it's a communication activity that's directed from the rover outwards. And then there is the activity of taking a photo, which it could conceivably do while moving, if so directed. These sort of seem like 3 individual activities of a similar scope, I guess.
So
Or simple level.
absolutely. Now imagine that you had an operating system. So the operating system would handle the moving, the communicating, and the taking a picture. So maybe you have 2 activities, walking and looking around. The communication would be completely invisible to the programmer. Right?
Well, I guess even for movement, for my simple rover, even if you ignored the details of engaging the motors, both the left side and the right side, the same value, and say that that's a low level thing that the operating system maybe takes care of. At a command level, it's saying, well, I'm going to move forward for 10 seconds.
Yeah.
And so I'm going to count to 10 and then I'm going to stop. Is that a low level thing, or is that
no?
It's conscious.
It's one
conscious
activity.
level.
I'm moving for 10 seconds.
Yeah.
Okay. I would expect your operating system to provide the service of, oh, the program wants to move, we're going to move. Okay. The program wants to take a picture, we'll take a picture. Okay. But that's it. The communication is not part of it. So it's not easy to have multiple activities. And not because any activities you suggest, I'm going to bundle them together and push them into the operating system. It's because of the way we talk about a rover. Perhaps if we talk about the Boston Dynamics. So it does incredible things. It's dancing to music. It's leaping from one place to another. But that's only one activity. And the reason why I'm bringing this up, and in order to give myself an out, we have activities that are event-based. In other words, if your rover suddenly hits a wall, maybe it goes back. So that's an activity which is event-based. If you hit a wall, this new activity happens called running away from the wall. Okay, but it's happening instead of a different activity. So if we ignore these event-based activities, and we think, for example, about a kitten, which I see is looking for something to chew in Venkatesh's room. What does it do? It's playing, it's chasing a mouse. One activity, okay? Chasing a mouse. Then it looks for a cable to chew on. That's a different activity. It found its cable, it's chewing on it. That's another activity. Decides it's hungry, that's an event. It goes to get food. Again, it's a single activity. Now, the reason I'm asking this question is because when we have a normal operating system, the ones that we use on a daily basis, they all have multiple activities happening simultaneously. Some of them are event-based and some of them are not event-based, but they're actually happening. So I was wondering if anybody could think of Rover doing, I said 3, but 5 activities?
The thing that, sorry, I'm getting a bit confused because I misunderstood. I understood something else earlier, because I was from the point of view of biology or biological analogy, and I thought that an activity would be what you talked about, but would also include the equivalent of metabolic activities. Okay, so if we take any of our rovers, okay, including Boston Dynamics and so on, it seems to me the standard is actually multiple activities all the time, but with the distinction between activities that we observer consider as the activity and all embedded activities like watching your battery level to decide, the equivalent of the metabolic of some metabolic mechanisms to when we are hungry on well here when we need to get to the charger basically. Okay, and charging batteries is one example, but there is also biological entities. Usually they have their understanding of their position relative to their environment. Okay, I forgot the name, but we have an internal ear and a kind of gyroscope for birds and so on. Okay, the rovers, rovers, robots more generally, often have something similar with an embedded gyroscope and so on. It's something that runs all the time, and that is necessary to maintain the guide and stuff like that, right?
Yeah,
Are all those activities in that sense?
No, I see I was missing a slide here. And what the slide would show is that the operating system provides services for activities done in a level above the operating system. And the services that are provided by the operating system can, of course, include multiple simultaneous internal processes, including checking your battery, shaking your leg to clear the sand automatically every 4 milliseconds, re-aiming your antenna as the satellite moves. So all of these things are naturally provided by the operating system. What I'm trying to figure out is where does the operating system end and where does the user usage of the operating system start? Because we definitely don't want to have a big, complicated program for each rover and each mission. But at the same time, when we think about traditional operating systems that do a lot of juggling, what I'm getting at is that a rover operating system doesn't have to do a lot of juggling of requests. It might have to do internal management of itself, but that's less interesting when we try to understand where BOS begins and where BOS ends. And maybe if you look at the next line, so some part of this complex called BOS Rover has a job of making the events that will trigger activities more or less likely. So if I have an event that says, if we detected water, operates this process, the rover is somehow trying to get to places where I'm going to find water. if I've, in Rhett's case, when I bang into a wall, I go back, the Rover might be trying to set it up so it won't bang into a wall. Banging is not that good. So there's things that are happening inside the BOS, and they're very complicated and multiple threads running at the same time. And I'm trying to find the line between BOS and, let's call it, application programming. So in view of that, services are what is provided by the operating system, okay? So activities is what is the operating system for? And the answer is it gives services to multiple activities. It helps you. But the operating system itself includes services. And Venkatesh gave a talk a few months ago, and we prepared a list of things that Rover should provide. And I added a bit, but yeah, a location service, a body sense, you know, knowing how it's positioned, something about environment. I could go on with the list. It's less important, but these are examples of services that we probably want to have provided by the operating system. So if I take a Rover and it has BOS installed on it, I have a system call that says, give me my location, give me my body sense, tell me what's happening around me. Seems to me that that would be inside the operating system.
So the way you're talking about this makes me think that two things. One is it's coupled to the choice of metaphor you use for interaction, because the activities sort of arise out of like the interaction mode. And depending on the metaphor, you might get a different definition and sort of cardinality of activities. So the way you're describing it right now, the closest metaphor that comes to me is actually a web browser. And there the abstraction level is the session, right? So each session is like one interaction group with one user, and that might involve multiple threads and multiple requests to the database and so forth. But within the metaphor of interaction between a human user and a website, a session is kind of the equivalent of an activity. And in the case of a rover, since if, for example, we pick the metaphor of a rover is like a website that interacts through a session-like metaphor with supervisors or requesters of missions, then the session becomes the activity equivalent. It might be go look at that rock, or send me the download of the last, I don't know, survey of that region, something like that. And that way, I can think of like a hypothetical set of activities that could be more than like one. So if, for example, there's 3 sessions running, 3 people are trying to talk to the Mars rover at once, and they're not in conflict, you could have 3 activities. In one session, it's the Mars rover is doing a drilling operation because I'm telling it to. In another session, it's sending you pictures from the last mission because you're asking it to. And in a third one, it's serving somebody else, maybe asking it to do a self-diagnostic. So in this case, I don't think this is what you're getting at, by the way, but I'm talking about the interaction between the metaphor and the definition of the activity, and therefore the definition of the boundary between services and the interface.
Wait, just let me unpack it. I'm not sure that a browser is a metaphor for me using a browser, but it is a metaphor for me using a rover. In other words, if we treat my rover as Chrome, and I can open a tab and get a page and run something locally on my computer, which sends requests to the rover, that is partly a metaphor, but it's mainly a type of abstraction. And absolutely, it means that if all 6 of us are connected simultaneously, okay, we could have 6 activities going on at the same time.
Yep,
But In the current Rovers, you don't do it. Okay. I mean, I shouldn't say it's easy to make up multiple simultaneous activities. For example, we can have a rover with wheels, and we simultaneously have an activity of trying to go from one place to another and leaving marks in the sand which look like a signature, okay, and scan to see if there are any aliens coming by. So we can have multiple activities happening simultaneously, but definitely rovers that people have today don't. Delivery bots don't. Okay, so the question I'm asking is BOS really like a traditional operating system, or is it something different? I'm not saying, you know, it's not middleware, okay, but let's take your metaphor of a browser. So that would be BOS, okay? From the user's perspective, I'm talking to a browser. Everything's good. I understand what's going on. Everything's good. But from the perspective of BOS, is it an operating system, or is it just, you know, a web server? Gets requests and answers them. It's not complicated, and that's why I had. Is it juggling different things? I don't know. I don't feel it. I don't know. Yes or no.
Okay, let's take one of the examples we have in this group, right? So Anuraj's rover system, if we call it that, is one ground rover and one drone.
Yeah.
And in some cases, they might be doing missions where they work as a set. In other cases, they might go off on independent missions. And you might send activity requests to the combined system, and it might independently decide that in this case, we'll act as one unit. In this case, it'll go off on two separate ones. So because a rover need not logically map to a physical rover, it can map to like some set of capabilities that are a subset of a rover system. So this is like what we were talking about last time, like a mission system is not like an ecosystem. It's like a set of capabilities that are like a logical abstraction bundle, and it can be unbundled in different ways. So you might think of like Anuraj's rover system as it either decomposes into a ground and a drone rover, or maybe it even decomposes into the cameras become one agent, and then the wheels become another agent or something like that. It could be decomposed in many ways, and then activities map to that. So I'm not sure I'm seeing. Yes, with a single physical rover, I think you'll be naturally gravitating to one activity. But if you start thinking in terms of rover systems or like complexes that are really multi-agent systems, you might have examples of like genuine multi-activity streams.
From my perspective, I think you just did exactly the opposite. There's one activity, and the operating system is providing the services using multiple components. In other words, if I want to know what's beyond that hill, okay, let's say I have a activity of seeing what's happening behind the hill. That's one activity. The operating system, which gets a request, which I have no idea what it looks like, decides, without even telling me, that it's going to send infinity one way and beyond another way. Okay, so this is a very sophisticated operating system, but activity-wise, I'm still only asking the system to do one thing. And like I said, I'm trying to understand, and the reason is because if juggling multiple activities is not an important part of the operating system, so we definitely shouldn't use that as a criteria for deciding where the dividing line is between BOS and other software. And most of the use cases that we imagine for rovers are go somewhere and do something, or maybe go somewhere and on the way continuously do something, like take pictures or look for aliens. Even as people, like I said, we don't usually do multiple activities at the same time, not at the higher level. So I'm putting that aside, and now I'm talking about the services inside the operating system, because in the end, BOS will have to provide services. And like I said, we talked about services. There were some items which feel like they should be services provided by the operating system, but it's not clear. So when I say machine learning, I don't mean will the system come with a library of functions. I mean things like the rover has to be continuously learning things. Is that a service provided by the operating system? Now, why should it be provided by the operating system? Because a lot of the learning improves the rover itself, not whatever program it is you're running. So if I take what Eric showed us, the rover is learning how to walk. So the better it learns, the better the rover is. So I want that to be shared between all the programs. So maybe I want that a service provided by the operating system. There could always be a component called a Jetson. Okay, size not here, but a Jetson Nano board, which the program accesses directly. But the learning itself is usually, at least the way we envision rovers, something the rover needs in order to get better. When it lands on Mars, it doesn't know enough. It needs to learn. So is it internal or is it provided as a service? What about AI? Talking about things like planning. Is planning something which is provided by the rover or something which is provided by an external program? Let's say the program I write. Computer vision. Okay, so on the one level, you know, if I'm looking for aliens, so I write a program that looks for aliens and I write all the code myself and I don't need the operating system for it. On the other hand, at some level, the rover has perceptual abilities, identifying moving objects, maybe identifying objects that have multiple legs, identifying flying saucers. At some point, perhaps it should be in the operating system. Obviously, traditional operating systems don't include these functions. They do include things like access to machine learning hardware, the same way they include access to graphical hardware. But with a rover, like I said, it seems part of the essence of a rover. Much more complicated is autonomy. And here I'm looking also, you know, we have reflexes, we have an autonomous nervous system which continuously monitors the homeostasis of our body. We have all sorts of control loops, like if I stop breathing, suddenly I'm going to stop breathing. If I feel a little ache, I'm going to move a little bit to feel more comfortable. This is a very low level of autonomy, and obviously it's provided by the rover. But what about by the BOS? Obviously, to me at least. But what when we talk about higher levels of autonomy, like where do we go today? Let's say I have a rover which decides where it's going to go today. This decision module, is it part of the operating system or part of the program? And the reason I'm asking is because a Rover with the ability to decide where it's going today is completely levels higher than a Rover which is not capable of making those decisions. So when we imagine an operating system, do we expect the Rover to have whatever level of autonomy it has? Or do we expect that we will provide it? By we, I mean people using BOS. Anybody have any feelings about this?
Just a quick parallel with traditional operating systems. So I haven't looked inside an operating system for a long time, but usually there are a bunch of tasks that the operating system provides. Okay, typically last week we were talking about scheduling, okay, process scheduling and so on, or memory allocation and memory strategies to release memory and so on. Okay, those are generic tasks provided by the operating system, but there are many ways to implement them. And actually, over the decades, there are new algorithms with different trade-offs on doing scheduling, on doing memory management, and so on. And so, in parallel here is that, for example, if we talk about machine learning or planning inside AI or computer vision, it seems the question is, are CV and AI and ML boxes in not boxes, tasks that the operating system are supposed to do, and basically to provide an interface. And after we have one implementation of each that fulfill that interface today for version 0.1. And maybe if we do well and we continue later, we will have version 1.7 of the CV box, basically. Is this how you see things here?
Yes. That's what it appears to be. Okay. In other words, I'm imagining that a Rover that has BOS installed on it is a Rover. It's not programmed, it's not trained, it doesn't know what to do, but it provides all the basic things, and it makes sense that you would have a planning module, and you can replace that planning module with a different one. Or you write a program which makes its own plans, but the operating system would still provide as a service the ability to plan to get from point A to point B. It just seems to me that yes, that would be, but I'm not sure, because I also don't want the operating system to do too much. But when I get to autonomy, it starts breaking down, because autonomy is the essence of what makes a Rover alive. So if I put it in the operating system, they'll all be the same. If I don't put it in the operating system, then the programs become very complicated, which suggests that maybe this should be provided as a service by the operating system, like a database.
To control the complication and complexity, perhaps it's good to start with a concrete and a restricted definition of what autonomy means. Okay? Because we can imagine a service like, okay, we imagine a Rover as an autonomous entity. For many people, autonomous means that it's untethered, basically. Okay, and so let's take that. It's valid. Okay, it's not. I think we're talking about something much more complex, but that's already valid. Okay, it should be untethered, and to be aware. Sorry for the word. Okay, but to have some mechanism to detect that we have low battery and then we need to charge. Okay, that sounds an isolated functionality that makes a lot of sense. That it's managed by the operating system, so that would qualify as a service, definition, right?
Yes, except I don't know what it means to provide that service. Okay, I have a car parked outside. It's an autonomous car. What does that mean? If you tell it, go to the butcher to buy some meat, it will drive me to the butcher's that has the address. Okay? And it won't bang into other cars. It will obey all traffic laws, won't run over pedestrians. Now, the car doesn't have an operating system. Okay? Because I, as a user, I just have one program running called Drive. I don't have other programs running. I can't program it to set up a party. So what does it mean that autonomy is a service? Does it mean that I get it and that's it? Or does it mean that I can ask for it? Can I ask for different, can I write a program which says, give me this in autonomy? And the operating system will provide me that in autonomy. I'm not even sure what it means, but that's what I would do if I were asking for memory. I would say, I don't care where you get it
Yes,
from, I need a
sorry.
block of memory.
So sorry, that's to bypass that situation that I was talking not about autonomy, but about energy autonomy. So a subset of what we mean maybe by autonomy here, something very concrete, and that looks like some service, some system service in let's say in Linux, some Linux terminology, a system service that says, okay, we are low battery, we need to do something about it. Create an event inside the rest of the system. Maybe we need to shut down some functionalities that are not critical. Blah blah blah. Okay. So it's not autonomy in general. It's about to start with some aspect of autonomy that are recognized and that are maybe useful to more of us, or maybe all of us in this case. And that looks like pretty clear that it may not be enough. It's definitely not enough, but maybe not the right thing to do. But that looks like fitting pretty well as a system service to cover battery autonomy, because it looks like basic in terms of survivability. Or is it a word that? But the survival of the robot, which comes back in many discussions about what autonomy can be in terms of scope. So it's clearly a subset, a very tiny subset. Sorry.
No, you are absolutely right, because when I was laying out the presentation, I didn't, and I should have, distinguished between inwards looking services and outwards looking services. When I was writing about services, I was thinking about things like location, where if I write a program on top of the operating system, I ask the operating system, where am I? Or body sense, how is my body? Or environment sense, what's the surrounding temperature, noise, wind, whatever conditions. So autonomy of the types that you're talking about, meaning internal activities which happen on their own and keep things happening, absolutely. But when I wrote this, what I was thinking of is, like I said, autonomy as a service. I ask the operating system, my program asks the operating system, some sort of user-facing interface. Not just that I can tell the operating system, be more careful, be less careful, but what does it mean that I ask it to provide autonomy? When I ask it to provide machine learning, that's easy, or planning. I tell it, I need to get from point A to point B, give me a plan, okay? So I'm trying to imagine the equivalent with autonomy. I'm not sure what the question would be, but I tell the operating system A, B, autonomy, and the operating system gives me an answer or does something.
Just one comment, like the inward looking and the outward looking services. So comparing to the traditional POSIX systems, so you have the low level kernel part of the OS and the user facing the user land or the user space part of the OS.
Yeah.
So for a rover, how would that look? So in POSIX systems, everything is a file, right? So for a rover, what would be like, what would everything be? In POSIX system, you do everything on a file, whether you insert a USB or you are doing anything, you are basically operating something on a file. So for if you're designing a rover system, what would the minimum unit be? That is something to consider. And then like it could be divided into the kernel space and the user space. So one way could be like everything is an actuator, and then they provide some affordances, and then the user land could combine these affordances to make some services.
That's a very interesting idea. I just want to ask, do you really think that in POSIX everything is a file, or maybe some things are not files, like semaphores or interrupts? The reason why I'm asking, because
but you operate on an like the things you do, it's always acting on something, and that is always a file. So interrupt, even if it does some activities, then it goes into a file.
so I'm trying to, I can definitely imagine what you're saying, that everything is an actuator, but some things are not naturally an actuator, like a body sense, okay, is a level of abstraction above actuator. That's why I'm asking, because I like what you're saying, everything's an actuator.
Yeah, so like in POSIX system, what happens is you have read and write and other activities on a file.
Right.
So in a rover, we could have an actuator and then move left or right or some other sort of activity which you do on an actuator. It could be something like that. So you have like activities or like affordances provided by the actuator, and then you could the operating system or the kernel code could use these activities on the actuator. So similar to what happens in a POSIX system, that you have a file and then you have read, write, or some other functions that you can do on a file.
I think, I'm not sure, that RoS has, let's call it, two primitive objects. One of them is a sensor, and one of them is an actuator. I'm not sure.
But RoS more or less seems like a communication middleware. So it allows different actuators to have a common communication medium.
Mm-hmm.
So, and it provides tools to make this middleware and everything work. But it doesn't, I don't know if that nodes can be called, because they don't have the concept of affordances of what it provides. It's like it's more at a even more lower level than what we might want in BOS. So it provides sensor readings, and then it provides it as a service, and then you can read at that stream. So that is a little lower level of abstraction that we would want.
Well, inside BOS, it's perhaps the right level of abstraction. User facing, maybe it's too low. But inside BOS, not unreasonable.
Something Anuraj said reminded me of a thread that came up when we were talking about affordances in your session, Anuraj, which is the idea of affordances doesn't need to stop at the body envelope of the rover itself. It can extend to the entire environment. So if there's a rock in the environment that you can pick up and use as a hammer, suddenly that can be sort of included in the logic of the actuator design space. And suddenly now you have a new actuator that you've kind of registered in the BOS equivalent of like, Windows registry that says, now I have a rock, I have a tool, and I can use it to smash things. And it can work in a subtractive way as well. Like if you lose a leg or a wheel, you're a lame rover, but you can still do things. So an actuator vanishes. So even though I don't think that does seem like too low level of an abstraction and probably internal to BOS, I think there's something important there. Like whatever you do end up defining as the activity level of abstraction, it has to like supervene on this actuator level. So supervenience in the philosophical sense as anything that is defined at the activity level is going to be sort of a function of what's available at the actuator level. So I like the actuator level as sort of the canvas on which you work.
So
I like it too. There is another based on what Venkatesh said. There is also the saying by some neuroscientists that perception is action, and we close the loop because the actuator is seen as the
well,
it makes the actuator really as the central piece.
so I would like the lower the object to be a loop, not an actuator. Okay, a loop has a sensor, an actuator, and glue. So I would prefer that to be the basic object, if I had to choose. Because I think when we talk about autonomy, that's what we expect to see. Some sort of closed loop. Any case, getting back to rocks, the point is that most of the rover, as a rover, forget about the distinguishing between the levels, are below the line of what's in BOS. Okay, so maybe I just have a very primitive conception of what a rover is, but it's like, people say you don't use 90% of your brain. So, well, 90% of what's happening in a rover is not us. It comes baked in. So one of the criterias for what could be above the line or below the line is, I think, do they affect the state of the rover, something that we're talking about, whatever it is? Does it affect the state of the rover, and can they be compartmentalized? The issue is, and I'll skip to the end of the slide, in a regular operating system, your program gets a virtual machine. Each program thinks it's running on a machine, not a real machine. It doesn't know about everything that's happening. And you can stop a program, start a program, rewind a program, and the program doesn't know. I mean, yeah, it could know, but it doesn't really affect what it's doing. And today we have it at the extreme when we have servers running as virtual machines that are running on servers running as virtual machines. And we don't even know how many level down goes. But with rovers, whatever you do affects the state of the rover, nearly anything you do. Many of your resources are path dependent, meaning it depends if you did A and then B or B and then A. Some of them are outside the rover. This rock that you just mentioned, it's outside the rover. It's not part of the rover. I still need to allocate it. In other words, if one activity will get to use a rock, a different activity will not be able to use it. If the rock has a flat bottom and a pointy side, and I flip the rock over, you won't be able to use the flat bottom. A lot of the resources have a low reliability, which means if one activity uses them, it could be that the other activity will not be able to use it anymore because it broke. Not because it was changed, but it's just broken. And The real world is not stable. Just because there's a rock there now and I plan to let the activity get it in 5 minutes, doesn't mean that in 5 minutes the rock will still be there. When it's inside the computer, nearly everything is stable. The real world is not forgiving. If I make a mistake, I can't undo it. So if you think about the operating system as juggling multiple activities, so there are not too many activities. If you think about the operating system as providing services, we talked about them, but if you think about the package of services being a virtual machine, the operating system has great difficulty providing a virtual machine to the programs running on it. So if we take, Venkatesh, what you said about it being a browser, imagine that every time you work on a tab, everything changes on the other tab. Okay, that's not how we work. I have a tab. You can probably say I have another, 20 tabs open in this instance of Chrome. I guarantee that nothing is happening in any of the other tabs which is affected by the presentation. If I wanted to, I could, but I can guarantee nothing's happening. But if we take a Rover, I absolutely could not guarantee that. Because while I'm working on the tab of let's drill a hole, Rhett is working on the tab of let's move 0.5 meter sideways. Something's going to happen here. Okay. And what that means is that not only can't we provide a simple virtual machine, but the whole field, and there's a very well-developed field of resource allocation, most of what's in there is not relevant for BOS. And last but not least, we're working in the real world, which means we also have opportunity. I'm in the bottom of a crater. I can go up to the right, or I can go up to the left. I can't do both. If I go up to the right, I can look for water. If I go up to the left, I can look for interesting diamond-shaped rocks. Okay? How do I allocate this opportunity between the two different activities? So I don't know the answer, but what I can say is we seem to be missing a lot of pieces when we talk about, use a metaphor of an operating system for talking about ROS.
I think in this list of problems, you've kind of already implicitly defined the metaphor. So the metaphor that leaps out at me from this is that of an economy. So I think we're all familiar with the Marvin Minsky Society of Mind view of AI, right? The AI as like a whole bundle of little agents that are like interacting socially. Now, if you add an economic metaphor or layer on top of that, then it sort of already addresses many of your things. For example, if there's a rock that two different quote unquote agents want to use, that's basically economic competition. The good is a rivalrous good. And you might have, for example, a bottom-up solution where the rock itself has agency and sort of goes with the highest bidder, and it sort of allocates itself to the highest bidding activity that wants it. So, and there are examples of this. I can't remember the name, but there was one space mission that managed low-level actuator type resources using a market economy. It was like literally the battery is going to like say, I'll give the amperage to the highest bidding process that demands it. So if the camera wants 1 amps and is willing to pay X units, it gets the camera. So I don't know if this was an actual mission or like a design study that somebody did. So this gives you an idea that the metaphor at the activity layer is an economy. The fundamental unit that you're calling an activity is something like an economic demand supply sort of market clearing epoch or something like that. And it also tells you that the interface to somebody who might request something from the economy would be something like an import-export thing, right? The boundary of economies are much more vague and nebulous compared to boundaries of like things which take instructions. So for example, if you're not in the United States, but you want the American economy to do something for you, it's not a simple matter of like send a request to the Federal Reserve and it'll tell the American economy to do something. It doesn't work that way. Maybe if you're a central banker, you can tell the American central banker your suggestion for lowering interest rates, but that's the only top level request you can make. But you can do things like you can go to the American marketplace and set up like a bid for, RFPs for I want this thing built, and multiple companies might sort of bid on the project. And that way it also handles many of these problems of conflict, rivalrousness, like the activity coheres around the resources that are actually available and sort of sorts the coordination problems out while doing the allocation. So the way you're describing all these things, it sounds to me like the activity layer is an economy, and you interface with it through the metaphor of an economy.
Well, I can't disagree, but the metaphor annoys me for two reasons. One, it requires a new style of programming, okay? And by the way, I'm assuming that negotiation, ability to negotiate, is a service provided by the operating system, okay? But the second reason it annoys me is because I want a simple virtual machine. That's what I want. And what you're doing is you're forcing every program to talk to the other programs. Okay, it gets complicated very fast. And I would like my operating system to solve that problem. Okay, when I have an operating system, when I go to the supermarket, I don't have to plan all the supply chains. I don't have to negotiate with the cashier about each price and each payment option. Okay, there's a basic operating system. Here's the products, here's the price. You have 4 payment plans. Choose what you want. Okay, it makes it much easier to go shopping. If you go to the market, the traditional Eastern Bazaar, you have to negotiate everything. Anything you buy takes 5 times as long or costs 5 times as much. So that's why it annoys me. I'm not saying you're wrong, okay? Okay, so basically, we don't know what BOS is, and I like talking about it as how to eat a watermelon. Okay, so if you're a hippo, you can just eat the watermelon. Okay. Keep moving. Okay, so it's easy to eat a watermelon if you're a hippo. I'm not going to show you this movie about how to untangle a yawn bath, but it's as annoying as it sounds. So what do we do about BOS? BOS is obviously like a watermelon, and we're trying to take a bite out of it. Second. So when I was at school, I studied physics, and they used to make fun of engineers and said engineers can tell you what the system's doing, but they can't tell you what happens at the beginning. They'll get confused by it. Only when you use basic principles of physics can you understand what's happening at the transient. But I'll take the following from it. If we look at the transients, it could give us some understanding of what is happening in the operating system. And one end of the operating system is when the rover wakes up. What does it do when it wakes up in the morning? Another one is what does it do when it goes to bed at night? The next step would be looking at events. What happens when certain events happen? How does the operating system, what services does it provide? And later we talk about failure. What happens when we have a failure event? But didn't do those last two. What I did do is I tried to write a script for what does a rover do when it wakes up. I turn on the rover, it runs a script. What does it do in that script? So do you see the code? take that to be a no. Okay, not a problem. So this is, it does have a line of code here. Okay, so it's not that it's only pseudocode, but this is supposedly a script that the Rover runs when it turns on. The operating system comes up and then it runs this script. So this is not an answer, it's mainly questions, but it's a suggestion. So the first thing we would do is read any environmental variables, like what is my name, or any other information it might have. Then we would probably do some basic integrity checks. We check that our software is correct. Maybe we read it from the blockchain. Okay, it's a reliable way of knowing that while the rover was asleep, and rovers, unlike your computer, they wake up, they go to sleep, they're in places where they can't be controlled. While the rover is asleep, somebody could have switched some code. Maybe blockchain is a very low-level part of the operating system. And I'll just say, when I say the blockchain is part of the operating system, I don't mean a blockchain operating system. I mean an operating system which uses a blockchain on a low level. For example, reading from it to get checksums. It doesn't need the blockchain. It doesn't do things using smart contracts. Okay, but it uses a blockchain in order to increase its reliability and so on. Then the rover says, what is its integrity level? Okay, as the process goes on, the integrity level will go up, because right now there's no connection. Maybe I can't talk to the blockchain on a different rover. Maybe I haven't looked around and seen that I have a big rock about to fall on me. Okay, now we would probably select which startup script to use. We have one for waking up from a nap, and one for waking up in the morning, and one for waking up after routine maintenance, and one for waking up after catastrophic failure. And again, that's the kind of thing you would want to read from the blockchain. In other words, an interesting thing would be when the rover goes to sleep, it puts on the blockchain, I'm now going to sleep. Here's my state. Here's my checksums. Shouldn't be a lot of numbers. And then when it wakes up, it says, oh, I said that I was going to go to sleep for 20 minutes while I power up. And here's where I'm supposed to start. Let's check that that's what happened. Then you have basic services. You have motors, you have sensors, you have logging, you have other basic hardware interfaces. And we start a safety lock. The rover shouldn't move until we know it can safely move. Kind of like when we sleep in bed, we don't fall out at night. I need to start connecting. Obviously, there should already be Wi-Fi connection, or whatever connection we use to talk to other rovers. If there isn't, we have to start a background process which will check it every few seconds. Communication is very important for a rover, not only for reporting what it finds. We'll see it in a second. Now I start secondary components. I have perhaps a human interface. I mean, I do have a human interface. I start running my blockchain node, but maybe this was done earlier. If I have a continuous learning module in the operating system, which continuously learns and improves what the rover does, I have to start that. And here's something else, continuous discovery adapter module. Let me explain. The rover has a motor service. which means you can give it commands and it will carry them out. I believe that inside the operating system, one of the jobs of the operating system is to make it easy for the rover to continuously discover what it can do and improve itself. That means that if I require the higher level programs to give precise instructions, I put all of the complexity of knowing what the rover can do at a higher level. Instead, if we have a layer which has this property, that any command that it gets, it will do something. I don't know what, but it will do something. Then the higher level software knows that whatever it does, it gets a response, and it's much easier to have a continuous improving loop. So this is a component of the operating system whose job it is to expose the motors not as complicated things that they actually are, but as some type of object, actuator, that will always respond to what you tell it. In any case, this is still a secondary software component. Now the rover wakes up. We need self-configuration. What does that include? What components do I have? Do I have all my wheels? Do I have all my sensors? Did somebody plug in a LiDAR while I was sleeping? Each component has its own self-check. We have additional self-checks for combinations of components. We want to check coordination. If I have a posture sensor and I have a motor, I want to see that they actually work on the same timing. Now I have to test that things actually work. So I make a little movement and see that these movements work. Now I have to test and configure the inert parts. So if you think about a boogie-based rover, it has a body. Does it have the body? Maybe somebody took a bite out of it. Maybe the body got bent in half by a rock falling on it. If I have a passive component, like the boogie rod, does it still work? So this is part of self-configuration, figuring out what works and what exists. And like I said, there's active components and passive components. Now we're improving the integrity testing. We have some sort of security system, obviously. We look for malicious code. We check to see that the autonomy is working. Again, I don't know what that means, but it seems that we need to do it. Now that we know what the configuration is, and we know that the robot is all there, hardware and software, we have to do the configuration. Okay, if my rover that has 6 legs wakes up in the morning and it only has 4 legs, something has to change, probably at the operating system level. It's not clear what type of reconfiguring of the operating system is. I'll just point out that in a regular operating system, if you add a component, you add a driver, you add memory, nothing changes. But this is equivalent perhaps of adding a CPU, adding a leg and removing a leg. So how much this is integrated into BOS, I don't know yet. We build a self model. I have 6 legs and they can move such and such. I have 4 wheels and they can move such and such. I have a LiDAR and a camera. Again, could be that we dynamically reconfigure, and it could also be that we have simply download a package, or we could perhaps download changes like, I'm a standard robot, but I'm missing a leg. I don't know the answer to any of this, but it has to be done, and it's at the operating system level. Now we start all sorts of behavioral components. Location sense, something like SLAM, posture sense, maybe some sort of sense of identity. Is there an emotion system which gives weight to what activities are more interesting? Watchdogs. Remember, a lot of the activity of the rover is event-driven. Part of it is safety-driven. So I have watchdogs running and telling me what to do. Which watchdogs do I need? We see below, above at the security setup. I have to set up error recovery routines. What do we do if something breaks? And like I said, we're dealing with the outside world. Anything can break. I start environment sensing. Now, let's evaluate the physical safety of the rover. Let's make sure we're not about to die. So, do I have power? Is the weather okay? I have to start a module, which we call situation construction, which somehow tells the rover what's going on. I have to check the posture. Am I straight? Am I standing like that? Now I can check my posture location risk. If I'm standing like that at the edge of a table, I'm at risk of falling off. If I'm standing like this in the middle of the floor, I'm not at risk of falling off. Alerts start coming in, so I have to handle them. And I believe this is a time where we start generating a risk profile, which tells me what alerts should I be especially worried about. One set of alerts at the edge of a table, another one in the middle of a field. So I'm just pointing out that until now, the rover hasn't done anything yet, except a few jiggly movements. If I can, I synchronize with the blockchain, and I check again that everything that I have is what I should have. I look around for orientation landmarks. When I went to sleep, maybe I set a landmark. I went to sleep in my bed. I expect to wake up in my bed, right? Not on the airplane. I generate some sort of position estimate. Maybe I'm using GPS, maybe I'm using landmarks. Local, where am I? Okay, rovers act on the environment. I make sure that my immediate environment is safe from the rover. Eric likes talking about the rover robot that wakes up and throws its arm out and hits you in the face. Okay, so we don't want it to do it. Now that we've done all of this, we can release the safety lock.
Maier, quick addition, in addition to where am I, you should also have a when am I test, like a basic clock integrity check to see if you've been asleep for 10 days when you thought you were going to be asleep for 1 day.
Well, that was here.
Oh, it was there? Okay.
Just a second. No. We had the startup, so it should happen
okay.
here. But
so there's a basic what time is it kind of check, and then sort of an exception handling check where you expected one night and it was like 10 years later or something.
oh, exactly. Now I don't know what it's going to do if it discovered it was 10 years later. I'm assuming it would. Okay, so I have some simple logic. How long was they out for and was it cleared? So there's some sort of behavior. Okay. So now, like I said, I released the safety lock. The rover is now willing to deal with the world, but nobody can tell it what to do yet. And it also itself didn't decide what to do yet. So first I check if there's some sort of ongoing mission. And if there is, it might be a mission-specific checkup. Maybe there's a smart contract on the blockchain, which is telling me something that I committed to doing or that I have to do or that actually controls me. There could be incoming messages which tell me what I need to do. In any case, I integrate all of the inputs and decide on priorities, but I don't do them yet. Here's where I turn on these steps. Ability to get commands from outside. There could be a base station. This is something we actually have for communication. Social sense. Rovers are not alone. So I have some sort of social network. Who's here? What are they doing?
So here, in the spirit of your previous checks, you can also do a who am I check. Like, did somebody switch your body and brain overnight and suddenly you're somebody else and you think you're rover X and everybody else around you thinks you're rover Y. So it's a joke with humans, but body switching can happen with rovers, right? Like, you can take a board out of one chassis and just shove it into another board.
So we have here in the self configuration, but I actually didn't tell him to check who he is. He just learns who he is.
So there's two aspects here, right? There's an internal consistency check of your internal configuration files, say your rover X, but then based on how everybody else responds to you, you might actually infer a different conclusion. That's the classic 80s movies where Tom Hanks becomes a boy and he wakes up and he has to figure it out. Yeah.
Yep. That's it. And now enough of the rover is working. There's some sort of setting that a minimum amount is working. And now I go to the what do I do now script, which is part of the main operation of the rover, and I'm ignoring that. And what do we do if it's not working? I don't know.
You do like Linux and you crash.
Okay, so it's already, I don't know, 9:30, and we're also losing people. So I'm going to put the slides up on, I'll put a link to the slides. So
Red suggested to share this pseudo boot script on GitHub, and I think that's a good idea because on GitHub or wherever, okay, but a place where we can comment, and GitHub may be good for that because we can comment per line, and maybe it could be useful for us to interact on the proposal basically.
This is on GitHub. Everything I do with the rover is on GitHub.
Okay, sorry, I was not aware of that.
No, perhaps... it's fine. It's fine. Everything is on GitHub.
So as Red was asking for that, maybe we can share the link on the. Yeah, thank you.
Okay, so I don't know. Next week is Anuraj.
Yes, Anuraj, and well, it's only the three of us right now. Maybe Anuraj is still online.
Yeah, I came for a shot.
Yeah, so you're presenting next week.
Yeah.
And one thing that I can't join next week. So Maier will manage the session.
Eric, you suggested that we, because Anuraj's talk is perhaps interesting to more people, we should perhaps promote it.
It's something we wanted to do. It's more than my proposal, basically. And so what I plan, I have a memo to send a message to the Yak Collective Twitter account the day before, okay? But I don't know if there are some, if each of us can also promote the event, that may be useful, because Anuraj content is pretty attractive for as a presentation for new people, right?
If you, I can send a quick email on the Yak Collective email list
Oh, thank you.
once there's an event.
So is there any promotional material or something?
We already have the slides, right?
Yeah.
Anuraj, will you be presenting from the previous slide deck, or
Yes,
would you
yes.
fork a new one?
Yeah,
Okay.
I won't be making a new slide deck. I will just be using the old one.
I think that's just fine. Yeah. So then maybe